Okay. So I will, as usual, start recording and upload them onto the YouTube channel, but I have opened a new playlist, my lectures at Init College and academic year 2021-2022. Yes? So I have moved the previous set of lectures to a lower playlist, and I have started updating new playlists. So you know what to do. You just to go home and if you want to study. But of course, I will put all the links and everything we need in Google Classroom. Okay? So you really don't need to look for something, but of course it will be updated before I go to sleep tonight. I cannot promise that I can do it before that. Okay? Okay, so let us start with this concept. Try to engage with me. This is not a very formal lesson. That's just a recap of what it's important according to the book for our future. So the first section in the book is polynomial. It's just going through the concept of a polynomial. Yes. Do you have any idea? Do you remember what? If you don't know the correct definition, no problems. But at least you can give me an example of a polynomial. If that example is good enough, then I understand that you remember something about what a polynomial is. Yes, Gustav?
Was it an expression with two unknowns?
No.
No.
Might be an expression with two unknowns, could be a polynomial, but in the broader sense, this is not necessarily that every polynomial is with something like that.
Okay.
And by the way, let us, now that Gustav brought this up, let me ask more precisely. Please give me an example of a polynomial in one unknown. Because I didn't care about this before Gustav said this, it's also possible. But let us concentrate, as the book is, on a polynomial in one variable. And give me an example of that. Yes, Hussein?
F of x is equals to ax squared, maybe? Is that
Ax squared. Okay, but give more specific. Instead of a, we can give a number. That's true. Okay, but let me write. And instead of f of x, even though f of x is completely okay with me, but because p polynomial starts with a p, it's common to call it p of x and q of x. I don't know, or r of x. These are the standard letters that usually we use for polynomials, but that is not necessary at all. If you write f of x is equal to x squared, it's a polynomial, that's okay with me, okay? But now let us explore. So we want to talk about the notion of a polynomial. Actually, what Hussein said has a more specific name. The example that you mentioned, let me just write it. So if you don't mind, let me write p of x instead of f of x. And then if you told me ax squared, if you don't mind, let me write 2x squared. Yes, that's a correct example of a polynomial. But probably you know what is the meaning of poly, yes? That's a prefix that comes more than one, yeah? So that's a polynomial. But here you have how many terms? In your example, 1. If you say that's also polynomial, I agree with that. But for this particular example, there is another name that it is not mentioned in the book, and it's called a monomial. Okay? So this, in principle, is a monomial, which is this particular case of a polynomial. So if you don't mind, let me just add 5 to it. Then it becomes a polynomial with 2 terms. But that was completely okay. But can someone else give me another example to see how it goes? For example, let me write q of x. Give me another example. Yes, please, someone else. Come on. The brain is frozen or not? Yes.
x squared plus 4x plus 5?
Yes. X squared plus 4x plus 5. Now my question for you is that in these examples, when you are mentioning it, I don't know if you are avoiding something or not. If not, that's okay, but you need to avoid something, telling me something. That is the definition of a polynomial. For example, can I use the square root sign? Yes? For example, can I write this Rx is equal to square root of x plus 5.
No.
Yes, this is what comes the difference between a polynomial and an expression. Yes, this is not a polynomial. There is something in definition of a polynomial. Now, can you see the difference? What is the main difference? So in polynomial, what I have to have, I cannot have non-integers as exponents. Yes. So what is another name for this? Do you remember from the previous math study? I told you that these are for. By the way, I will go for the bonus of not having the formula sheet with you in the exam. If you do not have formula sheet with you in the exam, and if you turn your papers blank, you will get 2 marks. Yes. Good.
And what about calculator?
No. Sometimes my questions need calculators.
Okay.
So if I can design questions that doesn't need calculator at all, then there is no bonus because you are not allowed to use a calculator. And if the question needs a calculator, you should have it. Okay. So there is no bonus for the calculator. But there is a bonus for not having the formula sheet with you. Okay? And I want you to remember, please all of you, even if you don't want to work it, but make your account on Anki today. That's a free. Of course, if you want to have the application on the phone for the iOS, it costs $250, but for the Android, it is completely free. And if you have a Mac at home, if you install it there, it's again free, but only, I don't know, for iOS. So I really recommend you to set up this account. I will try to show mine to you. It's really at the end of the lesson. I will try to teach you it. It's really, really helpful. I, as a teacher, can make you flashcards, but I cannot promise because I have a lot of things to do. For example, I can make a flashcard for Math 3C, and then you can download my flashcard into your decks and try to review them based on what I expect you to learn. But I cannot promise that. If I can, I will. Please do that. It's very important. And then, by the way, GeoGebra, we also need it. Please download it on your computer if you have already removed that. Okay, so the main distinction is that, if you remember, do you remember from last year, you can write a square root as an exponent. What was that exponent? Yes, Rocco, this time you...
For this one, it's x to the power of 1/2.
Exactly. So you write x to the power of 1/2 plus 5. By the way, because this board is not that big, if you cannot see, you need to change your place. Okay. Otherwise, I have to start writing from here, then the board would be very, very small.
Okay, so I need to charge...
No, that's up to you. Feel free. If you don't see, do not request me, write somewhere else. You change your place. Okay. Everyone, okay? Feel free to move around, okay? Okay, so this is important. You are not allowed to put a non-integer value for your exponent. If you see some non-integer value on the exponent, this is called an expression, but you are not allowed to call it a polynomial. Okay? Another thing is that we cannot have, so not a polynomial. So that's a polynomial, but this is not a polynomial because this is not an integer. Even negative integers are not allowed. Yes? So for example, if I write h of x equals to 5x to the power of minus 3 plus 3x plus 1, this is not a polynomial because even though this exponent is 1, which is acceptable, okay, positive integer, but this exponent is a negative integer. It's not allowed. Okay, so this is not a polynomial because of this negative integer there. Yes? Now let me ask you, do you think that this is a polynomial or not? Is this a polynomial?
No.
Yes or no?
No.
Yes, Tristan?
Polynomials can have division.
Yes, why not? You are right. This is not a polynomial. The reason is that, of course, you can say that I cannot have division. That's okay. But in principle, this, what is another name for this? 3x squared is completely okay. But what about this? Another name for this is 3x to the power of? Okay, good. So you remember. Minus 5. And then you have a negative integer, which is not allowed. So two properties you need to respect. You are not allowed to have an exponent which is not a natural number or 0. Of course, if I say what is the exponent here of letter x, you would say 5x to the 0, because do you remember x to the 0 is equal to 1 unless x itself is 0. So 0 to the 0, as I told you, it's not defined. Of course, some mathematicians define it to be 1, but I prefer to define it, it's not defined, okay? But except for that, x to the power of 0 is equal to 1 if x is not equal to 0. These are the things that you really need to have with you this year, if you have forgotten. So is that understandable? So that's a polynomial. But, by the way, do you know the name of these numbers? There is a name for this. It's in Swedish also is the same, I think, with the Swedish accent for that. So what are these numbers called for a polynomial? These are called coefficients. So remember this. Okay, I think the Swedish word is more or less similar to the same.
Yes.
Yes. So these numbers that you see appearing here, not in the exponent, they are called coefficients. I do not have any limitations at all on coefficients. Coefficients can be whatever they like. For example, do you think that this is a polynomial? So let me just repeat the name p here. P of x is equal to square root of 2 x to the power of 3 minus 4 over 5 x to the 2 plus square root of 3. Is that a polynomial? Yes?
Yeah.
That's a polynomial. So you see, if I ask you, can you name the coefficients for me? What are the coefficients? Yes, yourself.
Square root of 2, negative 5 over 3.
Okay, it's very good that you mentioned negative 5 over... Oh, I was crazy. 5 over 5 is just another name for 1.
Oh, I thought it was 3.
Yeah, I don't know. I imagined 3, so I actually induced my thought in your brain, yes?
Great.
Yeah. Extra sensory perception, ESP, something like that, yes? Okay. 5 over 3, and then?
Square root of 3.
Okay, so it's very important. When I ask you about the coefficients, include the sign as well as Rokudit, yes? So that's completely acceptable. The important thing is that if I ask you what is the exponent 3, it's a natural number. What is the exponent 2, it's a natural number. What's the exponent 0? It's also a non-negative integer. Non-negative integer. So that is acceptable as a polynomial. Okay, so that's it. And I will not give you questions. I have seen in the national exam, they list you some expressions and they ask you which one is a polynomial. And that you just need to check it out. Okay? So you don't need to define it, but you need to know what the meaning of a polynomial is. Yes? Yes.
Are we going to write a definition for polynomial?
No, I think if I want to write a definition, so definition as, okay, let me just write the definition because now I see that in the box, in the book, they have written something for the definition. Okay, but before going to there is something that you need to remember and that is important. This is the terminology, nothing hard, but you need to know. We talk about the degree of a polynomial. Okay, so that's a very valuable thing that you need to know. Whatever you read in literature, you see the degree of a polynomial. Do you remember what was the degree of a polynomial? Anyone else?
Was it
Yes?
maybe to what power the thing is raised?
Okay, so for example, what is the degree of this polynomial? There is a check mark, so that's a polynomial. I ask you, what is the degree of this polynomial? Just answer.
Degree.
What? Pardon?
Second degree.
Okay, so what is the degree? You are right. What is the degree? You are right. You are saying the second degree. It's grammatically wrong, yes? What is the degree?
2.
2, yes? You should say that this is a polynomial of second degree. When I ask you what is the degree, you just give me the number. That's 2. Yes, that's completely okay. How did you find that it is 2? It is the highest exponent appeared for the x. That is called the degree. So here, what is the exponent? It is not written, it is 1. This is 2, and this is here 0. So what's the highest one? 2. So that's called the degree, as simple as that. But you need to know the terminology. Yes? So the degree of this polynomial is 2. What is the degree of this polynomial?
2.
2. And what is the degree of this polynomial? This is not a polynomial, so the degree doesn't make sense for this. I cannot give you this and ask you what is the degree. You should say that this is not working here. And what is the degree here?
3.
It is 3, yes? Okay, a polynomial of degree 2 is called a quadratic polynomial. Yes? A polynomial of degree 2 is called quadratic. Okay, let me ask you, because I want to make you understand why they have written this here. It seems a little bit complicated, but I wanted to ask, how do you write? If I ask you, give me the most general form of a polynomial of degree 1, how do you write it? Let me make myself clear. If I ask you to give me an example of a polynomial of degree 1, what is the simplest possible example that comes to your brain? Comes to mind, yes? The simplest example, yes? X itself. P of x is equal to x itself, so this is the simplest possible first degree polynomial ever that you can write. But can you tell me what is the generic form? What is the general form that include all possible first degree polynomials? Yes?
AX.
No, more than that.
AX.
AX plus
B.
B. Yes? So this is the most general case. AX plus B. If I ask you, is this a polynomial? You would say yes, because it satisfies the properties of a polynomial. If I ask you what are the coefficients, the answer is A and B. And if I ask you what the degree is, the degree is 1. Okay? So here, can you tell me what is A in this case and B for this particular case?
1.
Yes,
0.
A is 1, B is 0. So if I put A equals to 1 and B into this general formula, it will generate this. For example, do you think that this is also a polynomial? Is this a polynomial of degree 1?
Yes.
Yes. Can you tell me what A is and what B is?
It's -3.
A is -3, B is -5/2. So it means that it is clear whatever you write as a first degree polynomial, you can generate it by this general formula by assigning appropriate values to A and B. Yes? Is that understandable? So this is the most general form of polynomial of degree 1. Can you tell me what is the most general form of the polynomial of degree 2? Someone else? Yes, Abdur? Yeah? No. This is one example, not the most general example. No one else? Just try to participate, otherwise you will fall asleep. Yes? Yes, Aaron?
What I'm thinking is ax squared plus bx plus c.
Exactly. Yes? So the most general polynomial of degree 2, I don't know, let me stick to letter P, even though this P is different from that P. So what Aaron is saying is this. It's completely true. It's the most generic form of a second degree polynomial. Now you understand what's going on. If I ask you what is the most general form of a cubic polynomial, someone else. Yes, Hussein?
Is it px equals to ax cubed plus bx squared plus cx plus d?
Exactly. This is the muhasib. So now, if I ask you, tell me a formula for higher degree polynomials, you need more alphabet. Yes? So here you have A, B. You have A, B, C. But finally, after, I don't know, 26 of them, you run out of alphabet. Of course, you can go to Greek letters, Chinese letters. It will keep you busy for 1,000 probably polynomials after that. But anyway, you will run out. So the starting point is using indices. Yes, I put an index. Instead of changing the letter, I assign an index counter. And for example, I say A, then I will not run out of letters, yes? I say A number 1 and A number 2. It means that I am considering them two different variables. They might be the same, but they might be different. One of them is called A sub 1, A sub 2. This is called an index plural form is indices, yes? So the best strategy is to use indices, otherwise I will run out of letters, yes? Now, using the idea of indices, this is what is written in this box. Can you tell me what is the most general form of a polynomial of degree, say, n? Not degree 1, not 2, not 3, but generically degree n, where n belongs to n. I want to write the most general form of a polynomial of degree n. Yes, this time.
I don't know exactly how to say it, but we something times x to the power of n, sub n, and then
Yeah, that's good.
basically
Yes,
so that
exactly.
it's,
Exactly. So I write a sub n, x to the power of n. Yes, and then I would the next term would be what? Definitely it would be x to power n minus 1. And if I call this the nth a, it's natural the previous one is n minus first n. Yes, so it would be a sub n minus 1. The next term would be a sub n minus 2 x to the power of n minus 2. And then I will continue until, for example, here I reach to a letter without any x. When I reach to the letter without any x, actually what is x here? I don't write it, but the power is, the exponent is 0, which I do not write. So it means that I reach to here a sub 0. X to the power of 0, yes? Which I don't write. What is the previous one? Can you tell me?
A sub 1.
A sub 1,
A sub
x. What is the previous one?
A sub 2.
A sub 2, x
To the power.
to the power of 2. So I think this is what is written, or the other way around. Now that's exactly what they have written in the book. So this is the most general form of the nth degree polynomial. If I ask you what are the coefficients here, you would say this number, this up to this one, and this one are coefficients. Where are they coming from? Generically, they are coming from the set of real numbers, any number that you like. In Math 4 that we will study complex numbers, they might extend to also complex numbers. So the coefficients can be complex numbers, but not the exponents. So the exponents has to remain non-integer values. But the coefficients can go from real numbers to set of complex numbers. Yeah, so you see, this is just a fancy way of writing, the most general way of writing. So I just want you to understand what is written in that box. Yes? Okay. One question that is very important for a polynomial, I think in Swedish it's called nollställe, in English we call it zeros. And then finding zeros of a polynomial after some step would be extremely hard and sometimes impossible to find exact values. Okay? So if I have a first degree polynomial, the question is trivial. If I give you this, everyone can solve this question. If I ask you this polynomial, be careful by the way, the methods that I present, I really want you to have a deeper understanding now. Sometimes, you see, do you see any zero here? No. I ask you to find zeros of the polynomial. It means that you take the polynomial, equate it to 0 yourself, and solve the equation. But sometimes I ask you to solve the equation. In this case, I mean, they are of the same thing. Yes, I'm doing the same thing but differently. Yes, you need to respect the grammar and whatever we use. So here, I give you a polynomial and I ask you find the zeros of the polynomial. This is, if I ask you what is this, you would say that's a function, that is a polynomial. That's not an equation. But if I ask you what you see on the board, you say that I see an equation on the board. Okay? They are different things, even though they are very related. If I ask you find the zeros of a polynomial, it means you yourself have to set up an equation first and solve it, and the answers that you call, you find are called the zeros of your polynomial. Okay? So if I ask you to find the zero of this polynomial, what do? You say that I put p of x equal to 0, and then the next step, p of x is 3x plus 4. I put it equal to 0, and everyone knows how to solve this, hopefully. It becomes minus 4 divided by 3, so that would be the zero of this polynomial. Is that understandable? Yes or no?
Yes.
Now my question is that, can you interpret this number graphically? It's very important, by the way. It's really important to understand what you are doing it at the level of algebra. This is algebra without any graphs and things like that. And what you are doing at the level of geometry, pictorially, yes, graphically. So can you have an interpretation of this number if you want to see this number somewhere? In this case, you just see it on the board. But if you want to see it somewhere, can you just tell me what to do? Yes?
You mean like put it in GeoGebra to see it in a graph, or?
Yeah, exactly. Can you tell me step by step, what do I put in GeoGebra?
Yeah, you just put x is equal.
For
to
example,
minus-
y equals to 3x plus 4.
Yeah.
So that would be a function. Yes, GeoGebra will draw a graph for you. In this case, you should be able to immediately anticipate what would be the shape. Would it be a circle? Would it be a curved object, or what? It would be a straight line. Because we learned that previously, if I have a first degree polynomial, its graph is a straight line. Yes, so these are the things that you need to remember from the previous lesson. Okay? Can you tell me if it was a quadratic polynomial? What was the shape? There was a name for it. Yes?
Parabola.
Parabola. Yes? And if you ask me what is the name for the third degree, I don't know. Okay? So there are no specific names for them, but we can study the properties of those curves here in this lesson this year by using the notion of derivatives and integrals. Okay, so now can you tell me, so Rocco was telling me, as we put this in GeoGebra, the GeoGebra will draw something for me. In this case, we already know that that's a straight line. Then where can I feel minus 4 over 3 somewhere in that picture? Where is it? Yes? Just yourself.
If you put in x is equal to minus 4 over 3, you'll see intersection.
Intersection of what with what? When you say intersection, you should be precise.
Yeah, they'll create two lines. One is a p of x and the other is x is equal to negative 4 over 3, which would be a vertical line, I think.
No, that's not the intersection of those things.
No?
Yes, you are right.
Okay.
But you are making it more difficult.
Okay.
So that is, so what do you want to say?
I would say that you would get y equals to 0.
No, I mean, where do you expect to see this number? Where this number pops out? Rocco said, but you made it more complicated. The intersection of this graph with, you said with the vertical line and things like that, that's completely true.
Yeah.
But simpler than that. The intersection of the graph of this with,
With the point.
no, with the, what is the meaning of the point, yes? With the x-axis. Okay, so that's simpler. What you said is correct. You said that forget about the x-axis, let us look at the vertical axis passing through that and then intersection. That's correct. But remember, if you want, so what is the geometric interpretation behind the zeros of a polynomial? It means that if you have the graph of your polynomial, wherever you see an intersection with the x-axis, the number on that intersection is a zero of your polynomial. Of course, in this case, we know that there would be exactly one intersection point. But if I have a parabola, what are the possibilities for intersection, the number of intersection points? Someone else, please. Only these students are answering questions. Please say something. So if I have a quadratic equation, so let me ask you, in general, let us pick this one. I do not give you numbers for A, B, and C. I am telling you, for every possible A, B, and C, what are the possibilities of the number of zeros, of this? Do you remember, if you want to answer this algebraically, you need to have good skills with algebra, factorization, solving equations. But if I give you the GeoGebra, at this level, you can start exploring this by giving some numbers randomly to see what is happening. But from your previous knowledge, you should know that I want to recap right now. What is a parabola? So of course the parabola, we haven't defined that, but you have a feeling something like this is a parabola. I haven't defined it exactly, but okay. So in this lesson, we have two different types of parabolas. What are they? Do you remember? Do you want to answer? Yes?
No.
No? Why not? Just answer. Do you remember, Hadia? What type of parabolas we have? Yes, Benjamin?
You're talking about the ones that go like this and the ones that go like
Okay,
this.
one opens up, one opens down. Yes? We had two things. Yes? Do you remember? Like, it's good to remember because that's a recap actually. And that's not something that you are embarrassed if you don't remember. That's the reason we are doing the recap. So, we have two types of parabolas in our lesson. One with all the parabolas have turning points. But this kind of turning point is a maximum point. This kind of turning point is a minimum point. Yes? Okay. Do you know, by looking at the function, by looking at the equation of the parabola, how should I immediately, without having the graphical tool in my hand, how should immediately I recognize which parabola is for my equation? There was a property. Do you remember? Yes, Maximilian, you want to answer?
I only know that the ones that go up are like for negative numbers, and the ones that go
No, be complete. Negative numbers what? You are right. You remember something, but it's not complete. What negative numbers? Yes, Abdullah?
negative A coefficient.
Negative A. So here, if A, only this one is negative, we don't care about the others, this should be of this type. And if A is positive, this should be of this type. Okay, so these are the recaps, okay? We talked about this a lot. We don't have time to go back to review everything in detail, why this is the case. If you have forgotten and you are interested, you would go back and watch the videos. But this is something. Now, let us ask you, what possibilities are there for the number of zeros of a quadratic polynomial? What are the possibilities? Imagine, I have here, so I have this quadratic, this coordinate system. If I have a line, how many intersection points I will get? One.
One or two.
No, for a line.
For a line, yeah. You
Yes.
have one intersection by the y-axis and one by the x-axis.
No, zeros are only with x-axis.
Oh,
Remember,
Zeros, just zeros.
zeros. I'm talking about the number of zeros for a first-degree polynomial. You are right. I can have a line which intersects x and y-axis,
Yeah.
but I don't count the intersection. That is another one. Do you remember what was that? The name for the intersection with the y-axis? It is not the zero. It is called
Y-intersection.
y-intercept.
Intercept.
Yeah, so that's called y-intercept. Zeros are x-intercepts. So those are zeros. For a straight line, in most of the cases, I will have one, but sometimes we don't have any if the line is horizontal. And sometimes we have infinitely many if that's the degenerate case. So you come just the x-axis. Yeah. So if I ask you y equals to 0, how many zeros are there for y equals to 0? It's a little bit strange to say infinitely many because all of them are intersection with the y is equal. So we say that it's not defined. Okay? But now let us go back to the parabola. How many possibilities are there? Just imagine. Yes, Aaron?
Are there 3 different types? So
Okay.
0, 1 or 2.
Yes. Why? Why is that? For example, if I have a parabola like this,
It's 0.
how many intersections you see? Nothing. So it should be no zeros. If it might have been something like this, then you will see 2. And in the extreme case, you get just a touch. Yes? So it means that you might have something like this, then there is only 1. And do you remember how this geometric picture translates itself into the language of algebra? Do you remember? What does it mean? Might be I'm a little bit ambiguous to clarify myself. I mean that if I ask you to solve this equation, if I ask you to find the zeros of this quadratic polynomial, what you are supposed to do? You yourself set up this equation and try to solve it. And do you remember what was the name of this equation? Yes, everyone? Yes? Just say it.
Quadratic.
Quadratic equation. And do you remember we had, once upon a time, we had a formula for quadratic equation. Yes, old days. So what is the formula for this quadratic equation? We had two formulas. Yes,
Only one.
made in Sweden, which is the PQ formula. I don't know, made in somewhere else, Britain or something. It's ABC formula,
Yeah.
which I prefer to use the ABC formula. Why? Let us review them. Definitely you need to memorize them, especially if you want to get the bonus points. I haven't thought about that, but I will try to do. I want to motivate you to start using your memory, okay? So here, if I have this equation, and I want to solve that, do you remember how I told you, let us concentrate on ABC formula, but of course I will also introduce you the PQ formula. So, someone else. You really need to start working on your memory, okay? So what's the formula? Only two person?
PQ.
No, PQ no.
Which one?
ABC.
It's right there.
Yes, ABC formula. If you remember, I introduced you something. Can you tell me, Jose?
What is it? Wasn't it like AC, so then the square root of, the delta divided by...
No, you should give me exactly. You cannot give me an approximate formula.
I
Yes.
use PQ, I don't use ABC.
So it's like me. You ask my phone number. I say that it's approximately this. Yes, you can call me. Yes. So what's the formula?
Should I say? Okay.
Yes.
X is equal to negative b plus minus the square root of b squared minus 4ac over 2a.
Thank you very much. It's not hard. You need to respect. Okay. So do you remember what was the name for b squared minus 4ac?
It's delta.
It's delta, which is called
Discriminant.
discriminant. Thank you very much. And it's also the same Swedish word. So delta is b squared minus 4ac. Okay? And then the x that I am looking for is minus b plus or minus the square root of this guy divided by 2 times a. And so that's the formula. Now, why do you think at the level of algebra I should also face 3 possibilities? Because as geometrical picture, I was facing 3 possibilities. It was very clear that I will face 3 possible cases, depending where the parabola is located. But now, how do you think I should also expect 3 possible scenarios when I am doing it algebraically? Yes, Rocco?
It's depending on if delta is positive, equal to 0, or negative.
Because delta is at the end of the day a number. B, A, and C are numbers. If you calculate this expression, it gives you a number. And for a number, there are 3 possibilities. You can assume 3 possibilities. Either the number is positive, or negative, or 0. So depending on the value that you get for delta, if delta is positive, how many answers you expect? Because if delta is positive, do I have any problem with the square root of delta?
No.
Do you remember a square root are only defined for non-negative values? Yes? Yes, I will have 2. Why? Because the square root of delta is a good number for me, is a defined number. Delta is positive. And then I once calculate x using the positive sign, and I once calculate x using the negative sign. Then it means that I will have 2 answers. Yes? So, 2 answers. It might happen that I have delta equals to 0. Then what happens? If delta is equal to 0, a square root of delta is one single number, and that is 0. Plus 0 and minus 0 doesn't play any role. It becomes just minus b, regardless if I am choosing the positive sign and a negative sign. So in this case, because this number is a non-zero number, minus b plus that number is different from minus b minus that number, so I get 2 answers. But if delta is equal to 0, this whole package becomes 0, and it doesn't matter if I am adding 0 to something or subtracting 0 from something, I will get the same answer. So this is why the number of solutions will be 1. And if delta is negative, the reason that if delta is negative, this square root of delta is not a real number. If we exclude complex numbers, then we do not have any solutions. This is why you do not see any intersection. So this would be 0, and if I want to emphasize 0 number of real solutions, but still I have complex numbers which we'll study math for. Okay, so this is extremely important, and let me just do it in passing. Why I prefer ABC formula over PQ formula? There is one reason for that. What is that? Yes?
A has to
Yes, in PQ formula A has to be?
it can be like that.
It has to be 1, 1.
Yeah.
If it is not 1, you have to divide by A to make it equal to 1 and then use PQ formula. The downside would be that when you divide, might be you start facing with fractions and you have to work with fractions, yes? Which I hate that. Okay, good. Yes. So you remember my master sentences, yes? So might be some, this is good. Okay, so here, I don't know, should I solve one problem for you? Yeah. Yeah, so it's extremely important. This is the final lesson that we are doing some recap. If you have forgotten, please try to review some videos. You don't need to watch all the videos. You just see the title and just see 15 minutes of that. If that's okay, you can just quote. So you need to review things. Okay.
Babak, are you going to review rationella uttryck too?
What is that?
Rationella uttryck.
Which page is that?
Rational expression.
Rational expression.
Not yet. This is coming later. I can talk about rational expressions as well, but let me just finish this. Let us start with solving one problem to see how you do that. Okay, I want to wait for you. So, can you solve this equation for me? Let me phrase it in the language of polynomials. So I would say example. Determine
Find x.
all zeros of the following polynomials. So we can say one, for example, p of x is equal to x squared plus 5x minus 6. So I want you to find all zeros of this polynomial. I think you can do it. I give you 2 or 3 minutes. It's not hard. I pause the video, wait for you. Please try, because I know that that's a very big gap. So if you do not start working, even if you know how to do it, please do it. You will train the muscle of your fingers. Did you solve this problem? Yes?
Yes.
Yeah, it is easy. I'm just trying to do some warm-up because I think you need it after a long break. So what I want to do, if you really want to go through details, I don't want you to go, because now you're in the 2nd grade. You really don't need to go through all these steps. But, and on the other hand, calculating delta first is a good idea, because if it is negative, you just say that there are no solutions, end of the story. And if there is one, this is not a waste of time, because you need it here. So I think it's a good idea to calculate delta here. But before delta, let me just repeat. You need to know what A is. A is 1, B is 5, and C is negative 6. You need to consider the coefficients. Of course, if they are positive, you don't need to be worried about. So b squared minus 4ac. So b squared is 5 to the 2 minus 4 times a is 1 times negative 6. And then you need to be careful a little bit not to mess up the signs. So this is 25. Minus 4 times 1 is minus 4. Minus 4 times minus 26 is positive 24. and then it becomes 14.9, and then you are relieved that there are two solutions because that's positive. And then what you write is the formula to try to remember it, finally, and then divided by 2a, so it becomes minus b plus or minus, minus, instead of b I put 5, plus or minus the square root of 14.9 divided by 2 times a. Just let me write it 2. And then 14.9 is minus 4 plus or minus 7 divided by 2. Then you face two solutions. X is equal to. One solution, you take the positive sign, and then it becomes 2 divided by 2, which is 1. And then the other one is minus 1. You pick up the negative sign, divided by 2, it's minus 12. And then divided by 2 is minus 6. So these are the answers. So, by the way, this is also good to know. Sometimes I ask you what are the zeros. So you would say that x equals to 1. And so if you want to write the answer, you shouldn't say x, because you need to change your question accordingly. Determine all zeros of the following polynomials. So what you need to provide as the answer is that 1 and minus 6 are zeros. But if I ask you to solve this equation, then you write x equals to 1, x equals to minus 6 are the solutions. Yes?
When you say 1 and 6 are zeros,
Yes?
what do you mean? That they are intersections with the y-axis?
So it means that, first, you can interpret it at two levels. Algebraically, it means that in this expression, if you replace x with 1 and calculate, it becomes 0. If you replace x with minus 6 and calculate, it becomes 0.
So
this is
p of x
algebraic.
becomes 0.
Yes.
If
So it means that in the function language, you write p of 1 is equal to 0. You remember what is the meaning of a function calculated at a point? It means that you need to remove all the x variables and replace them with this number. That is the meaning of p of 1. So p of 1 is 0, p of minus 6 is 0. This is the meaning. Yes?
Okay.
Yeah. Okay, so what happens for this one? Did you got any answer? Did you get any answers?
No.
No, there are no real answers if I am right here. Yes? So you got. So let us calculate. Let us calculate. You need to be careful about the minus sign. So here, let me calculate delta. But before delta, what is A? It's minus 3. What is B? Is 5. What is C? Is minus 6. Yes? And then I calculate delta. Let me repeat the formula to memorize that. So B is 5 to the 2 minus 4 times minus 3 times minus 6. Am I right? So this becomes 25. How many minus signs are being multiplied? 3. So finally it becomes negative. 4 times 3, 12. 12 times 6, 72. I don't need to calculate because it is clearly negative. So 25 minus 72 is negative. So here I would say that there are no zeros. This polynomial has no zeros. Yes? Yes?
What was the sign for or?
Okay, we use this. If you want to use the symbols, this is and this one is or.
Thank you.
You're welcome. Do you know when the lesson ends?
11:40.
11:40. So we have enough time. Okay. So the problem is that these two polynomials, the first degree polynomial and the second degree polynomial, are famous polynomials because we have a definite formula to answer the zeros, to find the zeros immediately. For the third degree polynomial, you can search on the Google. There is a formula as well, but the formula is more complicated. So still we can have it in our memory. I don't have it. It's complicated. So then you will get a formula. For the fourth degree polynomial, might be you should be able to find the formula. I don't know if we have it or not. But from number 5, from degree 5 onwards, actually Abel, the Norwegian mathematician, actually showed that it is not possible to find a closed formula so that we can find all the roots of polynomials of degree 5 or higher. It doesn't mean that we cannot solve any fifth degree equation. Yes, we can. It is possible that we have a fifth degree equation that we can solve it. For example, x to the power of 5 minus 32 is equal to 0. This is an equation. If I ask you, is it a polynomial equation, you would say yes, because if you do not look at the 0, this expression is a polynomial. And a polynomial is equal to 0. What is the degree of this equation? 5. Can I solve it?
Yes.
Yes. What is the answer? 2. So it doesn't mean that I cannot solve none of the fifth degree polynomial equations. Yes, but they should be of particular simplicity. In general, if you give me this equation, for example, so 2x to the 5 minus, I don't know, randomly 3x to the 4 plus 7x to the 3 minus 2x to the 1 to the 2 plus, I don't know, x minus 1 equals to 0. This is a generic fifth degree polynomial, and I don't think no one can solve this one exactly. But of course, mathematicians have developed, because first of all, we cannot have the exact value of this, but we can approximate the solutions. Okay? And this method has already been developed by mathematicians. So you need to first of all detect around which point the probable 0 is. And then if you detected that one using usually graphs and things like that, then you can get close to that root to any desired accuracy that you need in that particular application. For example, if you are designing a bridge or something, I don't know. For example, if you want to do, I'm just making up some stories. If you want to design a bridge, for example, you use physics to calculate the strength and the material that you need to use. Okay, for example. And you put those formulas in action, and then you want to understand something about which material that you need to use, what should be the resistance of that steel, for example, that you are going to use. You might face with some equation. This is just the complete story, okay? You might end up with this equation. And then you have to construct a bridge. That is a necessity. So then what you do, it means what? It means that you are facing a practical problem. Then you need to go and find the exact, approximate solution to that. Yes? Then it means that the engineer knows to how accurate he wants his answer. And the mathematician provides it. Do these steps, it will take you to the root up to this degree of accuracy. And for that engineer, that is enough. But might be that engineer want to make another bridge between Earth and Mars. And then it comes to this kind of equation, the accuracy that person needs to construct a bridge between, I don't know, two places on Earth is much lower than the degree of accuracy that he might need for making the bridge between Earth and Mars. For example, I'm just making stories, okay? But in that case, that is not a problem again. The mathematician tells you, okay, repeat this process more number of times, you will get a more accurate answer. Okay? So that is the logic behind solving higher degree polynomials. Okay? And of course, we can sometimes accidentally solve some of these ones. So you see a lot of problems in mathematical contests that might be they are asking to solve you asking you solve higher degree polynomial equations. because they are counting on your factorization skills, which is a hard skill to achieve. So that's why it is usually a good topic for mathematical contests. So I give you, for example, so some of them are simple. For example, let me just remind you. For example, if I ask you to solve this equation, so for example, let me just give you an example. X to the power of 3, if I can just immediately write it down, minus 3x. So let me write it like this. Let me write it plus 2x minus 3 equals to 0. For example, if I ask you to solve this equation, first of all, there are no formulas that you are aware of for the cubic equation. Of course there is, but that formula is complicated. But the story is the same. If I want to solve this and I do not have any formulas in my hand, so what I have to do, there is only one way to do that. What is that? Factoring this polynomial, which is not a trivial task in general. But sometimes you can, if you are a little bit smart or you have experience in it. But if you tell me, can I factorize this? No, I don't know. Yes, might be or might not. But this one, I can factorize, okay? So I just want to tell you that sometimes this is not even easy to factorize this. Let us just, by the way, factorize this. You just follow me. This is not part of your lesson. Factorization is a part of your lesson, but not probably the third degree polynomials like this. But I just want to see that this might be a little bit hard. So if I want to solve this equation, x to the power of 3 plus 2x minus 3, you just try to follow me that my steps are valid, not how I come up with this idea, okay? That's a different story. I just start with my polynomial. There are infinitely many ways that I can break minus 3 into two summands. I decide to break it in this way. So do you agree this equality is valid? Yes. Because what I have done, I have copied and pasted the first two parts, and then instead of minus 3, I have written minus 2, minus 1. So why that would be good? Because then I can write them in this way. I group them in one pair of brackets, and I group them in one pair of brackets. Yes? So what I have done, I have put them together. Everything is valid for the time being. Yes? And now, this, I can pull a 2 out. This is something that you need to know very well from the previous lesson. This is calling factoring 2 out. So this is 2 times x minus 1. Factoring this is not probably one of the formulas that you know, but this is always in the formula sheet. Nobody pays attention to that, okay? But let me just factorize it for you. So x to the power of 3 minus 1, x to the power of 3 minus 1 is equal to x minus 1 times x squared plus x plus 1. If you don't believe me, how can you test the validity of this equality? How should you do that? Yes?
You can multiply.
Multiply, exactly. So you multiply that. X times x2, x3, x times x squared, x times 1x, minus 1 times x squared, minus x squared, minus times minus x, minus 1. And then you see minus x and x are cancelled. This one and this one are cancelled. What is left? X to the 3 minus 1. So what I have...
In the formula?
Pardon?
Is that written in the
Yes, not with x. It is written with a and b. These are the formulas that you always have in the formula sheet. Here, a is x, b is 1. Okay, so this what I have written is correct. So let me write it here. Okay? And now you see that suddenly a new factor in common emerges. X minus 1 is a factor of this and is a factor of this. So I can pull x minus 1 out. So what is left here is x squared plus x plus 1. What is left from here is 2. Yes? And then what is this? Is x minus 1, x squared plus x plus 3. Agree? So I was able, but not trivially. If you don't have experience, why on earth I should break minus 3 to minus 2 and minus 1 and proceed as follows? It's not trivial at all. Okay? You need to be experienced. But I'm just trying to tell you that if I present a solution, you understand. It's like Sudoku table. Yes? Might be solving a Sudoku table is hard, But if I give you the solution, checking that this is a solution is very simple. And by the way, this is the more or less the same idea behind the cryptocurrencies, yes? Yeah. So like Bitcoin or something. Okay, so here, x to the power of 3 plus 2x minus 3 is equal to that. Okay, so instead of solving this equal to 0, because this one and that one are equal, I solve the new one equal to 0. Yes, I solve this one equal to 0. But why this is easier? Because what I have done, I have changed my problem to a new problem with the hope that the new one is simpler to solve with respect to the previous one. Otherwise, why should I do that? But do you really believe that this is simpler than the previous problem? Yes?
Yes, because we know how to solve it.
How?
So if you have, basically, it's either x minus 1 is equal to 0 and x squared plus
That is
x plus
what
1
do you remember the name of this rule? You mentioned it before a lot of times. You don't need to remember because that's enough that you know how to use it. But that's called the zero product rule. Yes? The product of two numbers is equal to 0. And that is only property of the zero number. If the product of two numbers that I don't know is equal to 0, there are at most two possibilities, yes? Either the first one is 0 or the second one, or of course both of them. Yes? So immediately from here, I can conclude that x minus 1 is equal to 0 or x squared plus x plus 3 is equal to 0. If I have done my homework properly till now, at this point I am relieved. Because I broke my original problem to two problems that I already know how to solve. One of them is the first degree equation, the other one is the second degree equation. And I do not have in general, in principle, any problems with solving those. So what is the answer to this one? Trivial. What's that? X equals to 1. And now I am looking for the answer to this one, but I do not have any problem with that. I calculate delta. Delta is b squared minus 12 for AC, which is minus 11. No answers. So how many zeros do I find for this polynomial? Only one. So it means that if you use GeoGebra to draw the graph of this one, you will definitely find exactly one intersection with the x-axis, and it occurs at x equal to 1. This is the only one. So now you understand, if someone asks you, this is what I want you to use as a take-home lesson. If someone asks you why solving higher degree polynomials, higher degree equations are harder, because factoring them is not a trivial thing, yes? And sometimes you cannot factorize it, because it's exactly like, because some polynomials are like prime numbers. You remember, if I have 24, I can factorize it. I don't know, I can write it 2 times 2 times 2 times 3. But if I have 7, I can just write 7. And the same thing happens for polynomials. Some polynomials can be reduced, can be factorized to smaller blocks, but some polynomials are called prime polynomials. They cannot be factorized more. Yes? And that the problem is that, and even if it is factorizable, it is not trivial as numbers. There are algorithms, of course, you can follow and factorize them, but it's better to use a computer. So is that understandable? Okay, so this is why I want you to feel that this is not a trivial question. I give you a question with higher degree polynomials and say that, okay, solve. No, it's not possible. By the way, I remember that might be some of you are interested, and I really motivate you to try to do that because you lose nothing. I registered the school for math competition for high schools, okay? And I really want you to try to register that. You might not be able to answer even one single question. Nothing will happen, yes? You don't lose something, but if you are able to somehow answer some questions, and then after this you go to national level, and then you start compete at the national level, and then if you are very talented, you will go higher and you will be in IMO team for Sweden, and then you go compete globally. If you reach to that point nationally, then you will have a very good career. You will have a very good opportunity for your future career. Yes? That's called International Mathematics Olympiad, IMO. Okay, so you can go and check the website to get some more information. But I think this is a good start for getting. You can also have some experience this year, even if you fail. Use that experience for the next year, and this is actually how it works. Okay, and that's a very, very good thing to do, I think. Yes.
Could you maybe like something like show us some of these problems for practice from the mathematics? Like, how do you plan to do? Like, if you wanna compete in it, like, are we gonna practice?
Do you know what is? It's in Swedish we say contest. Contest is translation of what?
Traveling.
Okay, so okay, that's exactly the word if I remember. So. Tävling or lig?
Ling. L-I-N-G.
Okay, so just go to this website .se. I think you get some good information regarding what would be the level of the questions and things like that.
But
Okay.
you're gonna be our coach, our trainer.
No, by the way, be careful. In those questions, I might not be able to solve the problem. Okay?
Are they that hard?
Yeah,
No, sometimes some of them are really hard. Okay? So you need to be smart. Okay? But what I'm saying is that you have to start. If you really like mathematics, you shouldn't be scared of being failed. Okay? You need to get experience. That's it. If you want to go to, because I don't know, I asked my students from the previous years, they even didn't dare to go there. I don't know what's the problem with stress. If you even get 0, nothing will happen to you. Unless emotionally you get some problems. Okay? And then I want you to go through it and try to control your emotion. Yes? You need to work hard. This is my advice. But there's always someone better than you. It's better to accept it from this age. Okay? Yes? If you do not accept that. But of course, for example, China start training the students extensively with so they probably start solving those kinds of problems from the beginning to the end. First of all, they have a very high competition among 1 billion people. I don't know how many students are there. They choose some very small fraction and they put them study 8 hours a day and then make them machine for solving problems. Yes? Yes. But of course, these kinds of tests, what I understand is that not just hard work will make you succeed. Okay? I don't know what is the situation, because here in Sweden, if you talk about these kind of things, it's like a crime, you know. But we have to admit that some people are, I don't know, they have more talent in some skills. For example, Terence Tao is the very probably famous mathematician of all times. He won the Nobel gold medal, international one, when he was 10. Yes? But usually these are for high school students. And he actually went to University of California and got his PhD in Princeton, and got PhD when he was 20, and he got a professor when he was 24, and he won the Fields Medal. He won 30. Yes, Fields Medal is like a Nobel Prize for mathematics. Yes, so, and I don't know if that's true or not. His IQ has been measured 230 or something. Yeah. Yes. So yeah. But how it works? This is but that person, for example, there is a conjecture. It's called Riemann Conjecture. When I was listening to one of his talks, he said that no, I don't think this Riemann Conjecture solution to that is a problem for our century. I have given up for next generation of mathematicians. Because he said that probably the mathematics is not so mature that we can solve this conjecture. So why should I probably waste my time on this problem that I know so hard? So let us keep it for next generations. Probably after a while the mathematics will glorify a little bit more so that we can solve the problem. Let me do something else now with my life. So I mean that is completely natural. So the only downside, especially the people, I just want to warn you, especially the people who get attracted to these things, immediately also attract to comparing themselves with others. This is something that I know from my own experience, okay? The second part is really destructive. The first part is constructive. So if you learn how to find the balance between these two, then you will succeed. And then, of course, by the way, Terence Tao is a big guy, but most of mathematics is not done by Terence Tao. It's done by a lot of mathematicians that Terence Tao is working after them. So, yes. Of course, being a mathematician in a university, you should have some kind of talent and eager for that. But of course, even there, we have a lot of hierarchies, you know. Yeah. So, yeah, we can probably stop here. And then I just want to know, I have it registered and I have asked Corinne that if they contact it, please let me know. And then I will let you know. And I want you to say, put this bad feeling aside and try to join there. Okay? And I will try to, so first I will go to this website and try to get some information. And sometimes we can discuss some of the problems together. You see that many of them I cannot solve myself. Or they are not coming instantly because they are not standard problems. When I give you this problem, this is a standard problem. So you can, but those problems doesn't need that much knowledge. So some of the problems cannot, even professors in mathematics cannot solve them, the international ones. It doesn't mean that the mathematics knowledge for solving is very huge. No, it's limited to the knowledge of a high school student. Yes? So the math professor definitely knows much more mathematics than a high school student. But the way that you have to start thinking might help you a lot. Many of very good mathematicians, for example, including Terence Tao, has been actually participating very seriously in these kinds of contests. Yes? Let us see how it goes. I'm just preparing your brain for that.
I try it. I mean...
Yeah. That's what I'm saying. You don't lose anything. And then if emotion comes, you need to be able to control it. Because if you do not learn to control it at this age, then this will actually destroy you. And if you want to go by this comparison yourself with others, it's not a good attitude at all. And I know the people who are attracted in these kind of things have a very potential to also do the other bad thing, comparing. Yes? So you need to learn how to find a balance with that. That's what I'm saying. That's my experience. Okay, thank you very much. I will upload the video and everything on Google Classroom, then we will see. Thank you very much. Bye-bye.